Good morning, everybody. I'm here with Mario to talk about the challenge 21 of ESoWC 2021, whose title is CAMS Forecast Air Quality Bias Correction by using in-situ observations. First of all, let me introduce us. We are two co-workers at a Spanish company. I've studied physics and Mario studied mathematics. And both of us have a master's degree in data science or statistics. First of all, I'm going to give you some background information why this challenge is important. Pollution affects everybody worldwide, and there are many people, around 7 million, who die prematurely as a consequence of pollution. This is why air quality forecasts are necessary and important in our society. First of all, in order to inform citizens about their exposure to these pollutants, in order to let them make decisions, very important decisions, such as where to live or where to spend the time with their families. Apart from that, secondly, it is also a tool for policymakers in order to prepare mitigation decisions that are taken on government panels and so on. This is a picture that shows a forecast made by CAMS and the observations. As it is shown, these forecasts are biased. There is a negative bias, which means that the model underestimates the pollution concentration. We can see that the observed forecast, the observations and the forecasts are separated. This is why the forecasts need a correction to fix these biases. The project objective is to improve the CAMS global air quality forecast using machine learning methods and observations at a set of locations which has been provided by our mentors. We are going to take the forecast from the CAMS and the observations to produce a data set with the features and the labels, and fit our machine learning approach to predict the error of the CAMS forecast. For doing this task, a list of locations has been provided, as I mentioned before, by our mentors, with the following format, like the city, the country, the location, and the point, which time zone, and we obtained the elevation using the latitude and the longitude point. These locations have a special interest for them because CAMS prepares air quality forecasts for the CNN regular bulletins. A period of interest has been identified from 1st June 2019 to 31st March 2021. We have used the whole period, but there's no all the information for all the locations of interest. The data has been collected from two different sources. We have obtained the observations from the OpenAQ using the OpenAQ API. OpenAQ is a platform, an open platform to obtain air quality observations on variables such as O3, NO2, PM25, PM10, and we used that tool. Apart from that, the air quality and meteorological variables from the forecast model, from the forecast, from the CAMS, was organized and given by the mentors. In order to prepare the big data set, it was taken into consideration that the CAMS forecast model has a very low resolution, which is 40 kilometers. So we had to interpolate the data to the point of interest. And now I leave the floor to Mario in order to explain some of the highlights from the obtained from the data processed.
Thank you, Antonio. Now I will be presenting some of the insights extracted while working with the data. First we saw is that most of the stations were biased, and this bias was very heterogeneous, depending heavily on the station location, the hour of the day, or the season of the year. In addition, the China stations were like 10 times more biased than any other station considered in the project. And we have also included here a link to access all the data visualizations produced during the project. In the next slides, we will consider a particular location that is Glasgow, where we can see a very clear positive bias in the PM 2.5 CAMS forecast. How this bias depends on the month of the year. In the next slide, we also show how our label correlates with the other CAMS forecast. Our label here is the PM 2.5 error, and as expected, it is heavily correlated with the PM 2.5 and PM 10 forecast, but it is also very correlated with other variables as the humidity or the temperature. On the other hand, in the right plot, we can see how this bias distribution change by the location, even for the stations in the same country. Lastly, we are presenting the model architecture we have considered initially, where we use inception time models to extract the temporal relationship between our variables, and we combine this with a multi-layer perceptron to get the corrections of the next 24 hours at an early resolution. So here we are considered as an input the CAMS forecast for the last day and also the next day, and we also consider like the previous error made by the CAMS forecast. This model has reduced the overall bias in a 25% overall stations. Lastly, here we include the GitHub repository to follow the development on the process, and the gallery with all the data visualizations. Thank you very much.